All right, I think we're live right now. Yep. We are live on the air. And I don't know if we have anybody viewing at the moment. Doesn't look to be that way, but I'm going to give people a couple minutes here to start, to show up. So if you are watching, hello everybody. Welcome to the WildPCS Arcane Exploiting Application RAM live event. We're excited to bring you this first event in our openness, sharing, and collaboration series. My name is Mike Harrington. I'll be your host and moderator for this event. And I'm just totally amazed at the response that we've had for this event. We've had over 170 people register for the event. I don't know how many people are going to actually be watching this, but if it's anything close to that, it far exceeded my wildest expectations, and so I'm very grateful and thankful to you all for that. So I wanted to again thank you for all of you taking the time to spend with us. I know your time is valuable. And before I introduce our guest presenter who's with us, I'd like to familiarize everybody with some of the format and platform if you're not used to Google Hangouts today. So we're going to have about 45 minutes of instruction. That'll be followed by about 15 minutes of Q&A. And we're going to have an additional guest that's going to come in today. That will be the MEM application author, James Nuttall, will be here today to answer any technical questions you have on that. So if you do type in some questions to the Q&A app, and I'll talk about that in a little bit. You do type in some questions to the Q&A app. If they are related to technical questions with the tool that our presenter will be showing, I'm going to ask you to defer those. Actually, I will defer those into the last 15 minutes so that he can address those. If they're also in relation to questions and answers, if there's anything that isn't addressed that I can see that people have really want to address when we run out of time, we will follow up with an email or perhaps a Q&A session, a live Q&A session, so that we can address those for you. So anyway, 45 minutes of instruction, 15 minutes of or thereabouts of Q&A. If there's some really pressing questions, as I see them come in, I will interrupt our presenter and address those there. If you happen to be watching on YouTube, on the video feed, should be on the lower left hand of your screen, you will see a link to join the conversation. That if you click on that link, it will take you to our Google Events page, where you'll be able to use the question and answer app. In reference to that app, or the Google Events page rather, if you're familiar with Gmail, you're familiar with that little grid thing that shows up in the upper right of your Gmail. You should have the same thing on the Google Events video feed. If you click on that, it'll reveal two apps. One is the question and answer app, and the other one is the Showcase app. I'm going to talk about the question and answer app right now. If you click on that, it will open up a sidebar on the left hand of your screen where you can ask questions. You can ask questions anytime you want during the broadcast, and in particular at the last 15 minutes when we do that. So when you ask a question, it'll appear on that screen. A neat feature on Google Hangouts is that you can +1 that and vote up a question. If somebody asks a question you think is particularly important, or something you really want to know about, I do encourage you to +1 it so that I get notified, and that I can make sure that gets answered. The other app you're going to see is the Showcase app. This app has a number of different links in it. They're relevant to what we'll be talking about today. Links to the repository for the tool on GitHub, links to the advanced Android forensics class we have at wildpcsmobileforensics.com, our JTAG class, as well as our guest presenters book. Let's see. Sorry, I'm reading my notes here. Again, 45 minutes of instruction. We'll pause maybe for questions if there's anything that's really pressing that comes up, but then we're going to have 15 minutes afterward. I want to address the giveaways. We are going to be giving away some prizes today. That'll be at the end of our presentation. If you registered on our website, you are eligible for those giveaways. I'll be choosing the giveaways based on a random number program I have, and I will notify those people live here today, and then we'll be following up with an email to you. Lastly, before I introduce our presenter for Android Arcane, I wanted to mention that this broadcast is going to be recorded and will be available on our Google Plus page, our YouTube channel, and at wildpcsmobileforensics.com on our blog. And if you would, you can like us on Twitter. We're at wildpcsmf, so wildpcsmf mobile forensics, and we have a Facebook page, same, as well as a LinkedIn company page that we would love for you to have you follow us on. So without further ado, I'm going to introduce our guest presenter. He's a uniquely qualified individual. I had the pleasure of meeting him when he worked at Basis with Brian Carrier's group. He's a recent author of the book Learning Android Forensics that was put out by PACT. His name is Donnie Tindall. He is a digital forensic engineer at Daga Forensics, where he evaluates smartphone application security for various use cases and provides unique solutions to any kind of challenging forensic issues you might have. Previously, as I mentioned, he worked for Basis Technology, where he was providing on-site device forensic support for the U.S. government, including development and teaching of mobile forensic courses to government and military users. He was a consultant to the FBI Terrorist Explosive Device Analytical Center, where he was responsible for mobile device forensics on media associated with IEDs, improvised explosive devices. He's performed countless thousands of mobile device extractions. He's done Nokia, BlackBerry, Android, and iPhone. He's an IASIS certified computer forensic examiner and instructor for the for SANS Forensic Institute Smartphone Forensics course, FOR 585. Without further ado, I'm going to turn it over to Donnie, and I'm going to go ahead and mute myself and take off my camera so that I can be focused on him, but I will be in the background monitoring questions, and you might see me pop up, in particular in the last 15 minutes. Okay, Donnie, over to you.
All right, thanks, Michael. All right, so like Michael said, I've been doing mobile forensics for about 6 years now, but this is the first time I've ever been involved with releasing a tool to the entire world, if you will, at the same time, and the first time I've ever done a webcast, so that's kind of interesting. It's weird knowing that I'm talking to a bunch of people, but I can't see them or anything like that. So please feel free to interrupt with questions, because I don't want to just feel like I'm sitting here talking to my screen. All right, so what we're releasing today, it's actually been out for a little while now, but a lot of people haven't heard about it yet, is a tool called MIM, M-E-M. It's an Android RAM acquisition tool. It doesn't do any analysis. All it is a binary that you'll push onto the phone. You'll tell it what app you want to pull the RAM for, and it will do that. Because it's a tool that's trying to acquire an application's RAM, you do have to run it as root. So that kind of limits the amount of use cases where it might be useful in an investigation. But there's still a lot of things that we think that it'll be useful for. Like Michael also said, I didn't write the tool. I don't do C code or any crazy thing like that. But a guy I work with named James Nuttall did. I just kind of drove the requirements and tested it and basically gave him a lot of feedback on what needed to be better. And we both think it's at a really good spot right now where hopefully it'll be useful to a lot of people. So first off, RAM, random access memory. It's memory that will be lost if you turn off the phone. It's volatile. As such, it's really important if you're going to acquire RAM that you have to do it obviously at the scene or as soon as possible, as soon as you can get it back to your lab before the phone battery dies or the phone is powered off for any other reason. If you turn the phone off, you're going to lose the RAM. And hopefully by the end of this talk, you'll see that there's a lot of good stuff in RAM that will actually be useful. Like I said, the phone will have to be rooted. I don't know what percentage of your cases involve rooted phones. I know I haven't seen it all that often, but the few times where it was rooted, I really wish that this had existed at the time. Some things that I think would be useful for example, the example I'm going to show today is Chrome. Google Chrome, most of you probably know, has incognito mode. When you're in incognito mode, nothing you do is written to the memory of the phone, to the disk. But everything you do is in RAM. So if I wanted to visit a page and I knew somebody might look at my phone down the road and I didn't want there to be any evidence that I had visited that website, I would do it in incognito mode. If you seized my phone, even after I'd closed that incognito tab, if I haven't powered down the device, that page I visited is still likely to be in the RAM. And that's exactly the use case I'm going to show you today. When I was writing application analysis for a bunch of random apps for the book, I came across an app called WeChat. And its entire database on the phone, it's a SQLite database, it's all encrypted. There are ways to decrypt it that are online, and I wrote about it in the book, gave some links. But also, it turns out, I noticed when I was looking at the RAM for WeChat, all of its messages are decrypted in RAM. So even though the application encrypts the data at rest, you can still get plain text messages through the RAM. So that's a couple of examples. Another example might be some type of malware. Anybody doing malware analysis on a live system is certainly going to pull the RAM. And until now, there wasn't really a way to do that for an Android device. So we hope we've addressed that need. One other thing that I thought of when I was trying to think of other reasons to use this is to see what the application is sending over the network. The way computers and phones are set up, it can't do anything, an application can't do anything without writing to the RAM. So basically everything it sends out over the network has to be written to RAM first. So you could set up an elaborate man-in-the-middle scheme if you wanted to see the exact packets and everything's being transferred. But I found that if you just look at the RAM, you'll find a lot of the network connections that are being made. And we'll probably see some of that today in Chrome. We'll see some different ad servers and things like that that it's going to connect to depending on the page you visit. And I thought that was interesting. Going back to WeChat as an example, because I was just looking at it earlier, I also found that it was sending out data about the Wi-Fi access point that I was connected to. It was sending out the MAC address and the BSSID. So I just thought that was interesting. It gives you, looking at the RAM gives you a deeper understanding of what the app is doing, because it's typically stuff that would be invisible to you. And now we have a way to at least look at it. It's worth mentioning that there is another tool out there called Lime, that stands for the Linux Memory Extraction Tool or something to that effect. And I wrote about that in the book too. And it can also capture RAM from Android devices. The reason that we wrote MIM to kind of compete with Lime, if you will, is that Lime is a kernel module that has to be loaded into the device's kernel. And that means you have to compile it for every phone, every firmware version that you come across. You've got to recompile it and push it to the phone. And it was super inconvenient. I don't think any examiner in the field at a crime scene is going to be trying to compile a kernel module to upload onto a phone. So our approach to MIM was to make it just a standalone binary. You send it to the phone, you tell it to run, and it does what you want. And I think we accomplished that. Hopefully you'll agree when we get around to doing the demo portion here in a few minutes. Another thing to note is, by itself, MIM is really cool. It will, like I said, it'll capture the application's RAM and write it where you tell it to. But to be forensically sound, it's probably a bad idea to write that straight back onto your evidence phone, right? If the phone has an external SD card, you could certainly swap it out and write it to there, but I know that's becoming less and less common. So what we recommend, what I suggest, is using Netcat as well in conjunction with MIM, and that's what we'll do in our demo today. And Netcat will allow you to write it out to your local PC that you're using to examine the phone. That way you're not writing any data to the phone itself to maintain the forensic integrity of it. I also suggest, for that exact same reason, when we push MIM to the device, we're not going to actually put it onto the flash storage of the device. We're going to push MIM into RAM, just to make sure that we're affecting the evidence as little as possible. Like I said, the phone has to be on during this process. If the phone's powered down, you won't get any RAM. So we're going to do our best to make sure that everything's as forensically sound as we can make it. So without further ado, unless there's any questions right now, I'm going to go ahead and I'm going to share my command line. because unfortunately, actually I'll talk about that for a minute. MIM right now, you have to run it from the command line. My goal in the next month or so is to release kind of a wrapper, a Python script for it that will actually do all of this for you in the background so that you're not messing around on the command line. If you go to GitHub where we've put MIM up, I've also got a README that will show you all the commands that I'm using today and show you exactly what you need to type to make it work. So hopefully you can do some testing on your own. We also say, please, if you use this, don't call us to testify in your case. Make sure you understand the source code. You know what the tool is doing. The code is on GitHub as well, so you can look at it and see everything that we're doing in the background. Test it in your lab on your own test devices so that you know it works. Don't just take my word for it. That's the beauty of open source stuff, is you can try it out for yourself. So please do. All right, so now I'm going to share with you my command line, hopefully. There it goes. The first thing that we're going to have to do is forward ADB. So ADB is the Android debug bridge. It's a tool that Google releases to communicate over USB with a phone. You will have to have USB debugging enabled on the device. We talk about it in the book. There's a lot of guides online for how to do it. So if you're not sure how to do it, look it up. It's really straightforward, assuming the phone is unlocked. And what I need to do is I need to forward that ADB port so that we can communicate with it using Netcat. That's a very important first step. Then in a separate tab, I'm going to log into the ADB shell. So this window right here that says root at Android, that's actually a shell that is open on the phone. So if I were to run any commands over here, they're actually running on the device, not on my computer. The next thing we're going to need to do is actually put our tools, MIM and Netcat, onto the device. I said we wanted to load them into RAM. So to make sure that we're going to do that, I'm going to cat proc mounts. And again, all of these commands and stuff you can find in the book. There's lots of good guides online. When I look at mounts, you can see there's a whole bunch of data that comes through because there's a bunch of different mounted partitions here. But what I'm looking for is tempfs. Tempfs in the Linux world means RAM. So you can see right here that the /dev partition is mounted as tempfs. That means /dev is RAM. So anything I push here, when I turn off the phone, it's going to be gone. So when I put MIM on the device, I'm going to put it in /dev. That way it's in RAM. It's not affecting the flash memory of the device. Nothing is permanent. We're minimizing the amount of changes that we're making. So we're going to put it in /dev. So real quick, in that /dev directory, I'm going to make a new directory and I'm going to call it, let's call it Webcast. Uh-oh. Let's see. There we go. Now if I look in the /dev directory, we should see a folder here called Webcast. And it looks like it's trying to make a liar out of me. Oh, there it is. It's up at the top. For some reason, it didn't get put in there alphabetically. So now we have our own folder in RAM that we can put our files into. So I have the files locally on my computer. If I go back over here to my terminal that's on my computer, if I run ls, you can see here I've got Netcat and MIM binaries that are ready to be pushed to the phone. So the command to send these tools onto the phone is ADB push the file you want to send and where you want to send it. So when I hit enter, this command is going to send the MIM binary that you can download on GitHub. The links in the the link is over in the links part of this. And when I hit that, we'll see that it sent it over very quickly. And now I'm just going to do the same thing with Netcat. And now if I look in that Webcast folder on MIM and Netcat are both there. So far so good. The live demo hasn't gone crazy yet. The next thing we need to do is make both of them executable. If I try to run either one of these right now, it's not going to work because they don't have permissions. Oops, sorry. If we look, they both have read and write permissions, but neither tool has execute permissions. So we're going to go ahead and fix that. I'm just going to change into that folder to make it a little simpler for us. And the command to do that is chmod +x mim. And now if I look again at these files, you'll see mim is actually highlighted in green because my Mac is smart sometimes. And now it has that execute permission, so we can run mim if we wanted to right now. I'm going to repeat that for Netcat. And now you'll see they're both shown as green. They both have the execute permissions. So now we can run our tools. That's great. That's awesome. That's exactly what we want to do. What we don't know yet is what we're going to run our tools on. So real quick, I'm going to unshare my screen. Hopefully we'll get some video back. And on my device, I'm going to open up Chrome. If it wants to cooperate. This is an HTC Droid DNA that's rooted. Like I said, you have to have root permissions to do this, but it should work on any Android phone. I've tested it on this. I've done it on a Galaxy Nexus, a Nexus 5, and a Samsung phone, as well as a couple of different tablets. So on my phone, I've got Chrome open. It's Google, and I'm just going to go to Netflix, I guess, as an example, because that's the first thing I thought of. And hopefully on the screen here, you'll see the Netflix homepage load up. So now we've got some web browsing going on. Maybe I'll go to another page. Let's go to NHL.com. Why not? The Stanley Cup's going on, so it seems appropriate. But we'll go hit another page. And hopefully now Chrome should have lots of good data and RAM for us. So I'm just going to set the phone down. Again, don't turn it off or the RAM's going to be gone. I'm going to go back into my terminal and share that with you now. And now we're going to see what processes are running. I want to find Chrome. So the PS command in Linux and on Android is going to show you all of the currently running processes. And as you can see, there's a whole bunch of them. Most phones have hundreds of them going on in the background. But I want to find Chrome, so I'm going to use pipe to run PS again and send its output through grep, looking for the word Chrome. And now you can see we've got two entries here for Chrome. One's Chrome Sandbox and one is the proper Chrome application. This is the one we're going to be interested in. What I need from this is the process ID, which is this second column over here. If we scrolled all the way to the top of our original PS, you'd see that that column is the PID or the process ID. That's the number that we need to give MIM so it knows what application to look at. So in this case, the PID that we care about, the PID, is 17546. So I'm going to run MIM, and I'm going to give it that 17546 process ID number of Chrome. And then, like I said before, if we wanted to write this out to a file on the device's memory, we could. I could just give it the path SD card, and we could just call it chrome.bin. And that would write it out to the SD card. The problem with that is this device doesn't have a removable SD, so I would be overwriting evidence. I don't want to do that. So instead of writing it to the device, I'm going to use pipe again to send the output of that command to Netcat. And I'm going to use -L-P. Depending on the version of Netcat you find, these flags might change. You may have to play with it a little bit. You may have to read the manual or the usage statement that comes with it to figure out what flags to use. But I'm going to tell it to send it out on the port that we forwarded earlier. Earlier over in this other tab where we did our ADB forward, we forwarded port 9999. So that's the port that I want to tell Netcat to send the data out on. So now I'm going to go ahead and hit enter. And hopefully, if everything goes right, the live demo will actually work. All right, we hit enter. Nothing has happened yet. It's still thinking. What it's actually doing right now is waiting for that port 9999 to open up so it can send the data. So back on my local machine now, I need to open Netcat on this side to get the data back out. And I'm going to send that to a file. Let's call it Chrome Webcast.bin. Now I'm going to hit enter. And what Netcat will do is it's going to open that port on 9999. It's going to take the data that's MIM is writing out and send it through to a file called Chrome_Webcast.bin. So when I hit enter over here, you won't see anything going on. Just know that it's working in the background. One way that I can check and verify that this is working is I'm going to go into the folder where I'm writing this to. And if I just run an ls here, you can see I've got a file called chromewebcast.bin. If I look at the size of that file, right now it's about 159K. If I do it again, it should have been getting bigger, but it looks like it isn't. Maybe Chrome just didn't use as much memory as I thought this time. That would surprise me. Usually when I've been doing this, it's been a couple hundred megs. But that's okay, we've got an output. If it's not changing, then perhaps MIM is done. Like I said, that seems really small. I didn't expect it to be done already. But let's go ahead and take a look at that file that we just wrote out and take a look and see if we can find our Netflix and our NFL browsing data. So I'm going to unshare this screen. And real quick, I'm going just to throw that Chrome webcast file that we made into a hex editor. And then I'll share that with you guys. One problem, if you've ever looked at RAM on a Windows box or any PC, it's just a giant blob of unstructured data. Like I said, usually when I do Chrome, when I've been testing it, I've gotten at least 100 megs. Sometimes the file is 500 megs. And it's just blobs of data. There's no structure to it. There's no file system. So if you don't know what you're looking for, it can be really hard to find the data that you care about. But that's just kind of the nature of the beast. The way I look at it is I'd rather have the data and have to struggle figuring out what it is than not have it at all. So now I'm going to try to share with you my hex editor that I just threw that in, which looks like it's not cooperating. There we go. All right, so on your screen, you should see the hex dump of that Chrome webcast we just dumped out. And like I said, if you just look through it, you're gonna see a lot of zeros. There's gonna be a lot of random data. And it's just not very fun to go through. But since I have the advantage of knowing that we went to Netflix, I'm just gonna search for Netflix real quick. And it's not there. That is odd. But that's how web demo or live demos go, I guess. Welcome to our tool. It's awesome. It just didn't work this one time. I swear it does every other time. All right. So what I'm going to do is I'm going to try that all again and hope that this time it works. So I'm going back onto the phone. Just going to do some more browsing real quick. Netflix and NFL. I'm going to delete that Chrome webcast file we just made. On the device, I'm going to look again at the process ID, the PID of Chrome. Make sure it's still the same. And it's not. It actually looks like Chrome crashed while we were, maybe that's the problem. Chrome might have crashed while we were doing that. Stupid phones. All right, so now we have
Donnie?
Yeah.
I wanted to interrupt for a second. I don't know if anybody has any questions, but if they do, they can pop them into the Q&A app. But I'm going to ask you one. Is there any way of knowing when an app will crash like that, other than you got a little bit of an odd output? I mean, that's an indicator, but do you anticipate building any kind of error reporting into that?
That's something we could look into. Usually I would just be watching the phone, so I would have seen it crash.
Okay.
You'd actually see the window close and come back up.
Okay.
It's definitely something we can look at adding into the tool.
Okay. I'm going to ask real quick, anybody have any questions that they want to ask Donnie right now at the moment while they're fresh in your mind? Just pop them in the Q&A. If you pop on the grid, if you're looking at the feed, there's a grid in the upper right. You click on that, and you'll see the Q&A app, and you can type it in there. Okay. Well, if you do, go ahead and use the app. and I checked. I don't think there's anybody watching on YouTube. You can ask a question, and we'll answer it. I'm going to probably not answer until James comes on in about 15 minutes. Okay, Donnie?
Sure.
All right. Back to you.
All right. Like I said, we've got a new process ID for Chrome now, 22672. So I'm just going to try again. I know the definition of insanity is doing the same thing over and over and expecting different results, but like I said, I've been doing this a lot lately trying to get ready for this, and that's the first time I've seen it fail. All right, looking good. Let me check on the device, and Chrome is still open on the device. And let's just see what happens this time. Oh, now you can see our Chrome Webcast is a much bigger file. So this looks like it actually worked this time. Yeah, as you can see, it just keeps getting bigger and bigger. Over 4 megs now. 62 megs now. So this usually takes a couple of minutes. Writing it out over ADB is very slow. Whereas if you're writing it to the device, it would have finished already. It takes less than 10 seconds when you're writing it to the device. It's just the process of trying to transfer it over USB back to my computer that's slowing it down. You know, now we're up to 119 megs.
Donnie, how many megs is that good? Do you think that's going to be?
If I had to guess, I'd say around 500.
About 500. Okay. Well, we have a question while we're waiting for that to finish. So this question comes from, and I apologize if I mess up your name. I can get the first one, the first part. This is from Miroslav Bacha. I believe that's how you pronounce his name. And what he's asking is, what is the difference between using the UFED, ADB, and MEM in process of acquiring memory? What's the difference between the two of them?
I've never used UFED to acquire RAM.
Okay.
I haven't used it in probably 2 years now, so I didn't even, that wasn't a thing back when I used to use it. But I would say the big difference is here you can look at our code and see what it's doing. I've never seen Celebrite release their source code to show you how it works.
Okay. All right. Hopefully that answered your question, Miroslav. If not, we can, you can ask another question and we'll address it. And maybe we could follow up with you on that. I mean, obviously, too, if you don't have a UFED, you can use MEM. It's freely available. That's one thing that is available out there to people. And I believe that Celebrite might provide testimony. I mean, I know you guys, obviously you don't have the resources to do that, but they may send people out. But I think your tool alleviates that because you're freely providing the source code, so people can look at it and know what it does, or should know what it does. And like any tool that out there that you're using, you should test it and know what it's doing prior to that, and not just accept that something is doing what it needs to do. It's always good to have more tools in the toolbox, obviously, and we'll and to test it out. So Miroslav just responded, said that he's going to test and he'll let us know. Great, Miroslav. When you let us know, we'll let everybody that signed up know as well. So I'm going to turn it back over to you, Donnie, and we'll go from there.
Storing our file. So anything else you want to talk about real quick?
Well, I've got another question. What do you commonly use to root phones, Donnie? Are you using a variety of different tools, or?
A great question. I know the forensic tools Celebrite XMA have it built in, which is fantastic these days. For the most part, I've had a lot of luck with Superoneclick, which is an EXE you can find out there. It works on a vast majority of devices. For this model, I rooted it like 2 years ago, so I don't remember. It wasn't Superoneclick. It was actually a process. You had to go through HTTP to unlock the bootloader and all sorts of other. So it basically depends on the model of your device. I would recommend Googling that device, especially on the XDA forums, and see what people are using out there.
Okay. I'm going to turn my camera off just to see if that helps with a little bit. I've got a little bit of lag on my end, and I want to make sure that people can hear us and effectively. When you're pushing binaries onto the RAM, are you using custom compiled binaries, or are you using something that something you found on the internet? How are you doing? Like for Netcat, are you using a custom ARM compiled
yes
binary? Yeah.
It's also in the same link as mine. There's a Netcat directory there you can look at. I've got a readme that tells you where we found it. It was an FTP site from NetBSD. They happen to have one that's compiled for ARM. So yeah, we definitely write Netcat. I just found somebody's out there testing it on some devices, and we're running with it.
Okay. Apparently, we're getting some feedback from my microphone, so what I'm going to do is I'm going to mute my microphone. Donnie, if you could just look at the chat that we have. I'll ask you a question on chat. That way, people can hear what you're saying. If there's feedback on my microphone.
So in the book, we don't go into great depth on Linux. We do describe every command that we use. So PS is described, DD we go into a lot of detail with. Basically all the common forensic things that you'll do in Linux, we definitely cover probably about a paragraph or so on. But we don't go into great depth on Linux itself. We do go a lot into the Android architecture and the file directories, the file system, that sort of thing. And a lot of that is very equivalent to Linux. And it looks like our file has finished copying over now. So I will jump back over to that command line real quick and let you see if it will let me share the screen. There we go. So we can see now our Chrome webcast.bin. Let me clear this so it's a little more readable. You see it's actually 585 megs. So I guess pretty close to how big it should be. Yay. Like I said, I've done this a few times. So I'm going to throw that into a hex editor again real quick, and then I'll share that with you guys. Actually, before I do that, let me go back to the command line. You don't have to look at it in a hex editor. There's lots of things you can use to analyze it. You could throw it into incase, FTK, insert your keywords. You could simply run strings on the file. But you're going to get a bunch of data. Like I said, there's a lot of garbage data in RAM, a lot of stuff that you don't care about, things that just simply aren't going to matter. I don't know what most of this even is. But again, just to show what a mess looking at RAM can be. It looks like here we've got some settings for Chrome. That's kind of cool. But I don't know that they'd be useful for anything that we care about. It just happens to be a lot of strings that show up. So again, I just want to show you an example of what a mess looking at RAM can be. Now I'll go ahead and I'll throw that into the hex editor real fast for you. In theory, it'll work. There we go. All right, now let me share this hex editor. All right, and let's try looking for Netflix again, since I'm pretty sure it should be there now. It did not show up. Do NHL? I think I did NFL the second time. I did find NFL. For some reason, it did not find our Netflix data in the RAM. It may have gotten overwritten. It may have been unallocated from Chrome when I went away from that page. You just never really know with RAM, but I did go to NFL.com that time. And you can see there's actually a lot of hits for NFL. You can find it all over the place. RAM is like that. A lot of times you'll find the same data duplicated over and over as different blocks are allocated and overwritten and rewritten. So it looks like we got 25 hits for the term NFL, which is interesting. If you were to just try a regex, if you wanted to, which I'm not going to do. Oops. 1 second. Is that still shared? Okay. I exited out. Anyway, if you were just look for HTTP, you would find, man, I got to stop sharing for a second because where I'm trying to type in that search field is blocked by the part that says I'm sharing the screen. All right, let me reshare. Like if you were to just look for HTTP, you'd probably find, 547 hits. There's lots of useless hits in here. Most of them, like this one, they're going to be like SSL certificates that are stored in Chrome or that Chrome is using to make HTTPS connections, that sort of thing. So if you're searching for keywords with regexes and that sort of thing, you're going to find a lot of garbage hits that you don't care about. That's just kind of the nature of what we're doing here and what the RAM is, what it's for. Here's a GoDaddy certificate, for example. So like I said, looking at RAM can be a mess. It's not very fun. But if you suffer through it, there can be data that's useful. Like I showed you, we found the NFL website that I had went to. If I had looked at that in incognito mode and you imaged my whole phone, you would have never known that I went to NFL.com unless you happen to look at Chrome's RAM. So I think that about covers it for the live demo portion. One of the things I want to look into doing, but it's going to be very time consuming, don't expect it anytime soon, but we would in the future like to add a plugin or some sort of support with volatility to help parse our RAM dumps. But like I said, that's off in the future. Right now you're stuck with a hex editor using strings, in case, whatever you want to use to keyword search. It's not fun, like I said, but it definitely pays off. You may find data that's encrypted on the phone, not encrypted in RAM, all sorts of stuff like that that could be very useful for an investigation. And that's about all I got, Mike. Are there any more questions right now?
All right. Hopefully you can hear me. Is that right?
Yep.
All right. Hopefully there isn't feedback. Anybody have any questions for Donnie? Oh, there's a bunch in here. So, somebody wants you to repeat what you use to root phones.
Okay.
Grant Melton does.
Superoneclick, all one word, Superoneclick. I've found really useful on a wide range of devices. A lot of times it works. You click a button and it does it. It has some really common exploits built in, and it basically tries them all until it finds one that works. But other than that, if you don't have Celebrite or X-Ray that will do it automatically for you, a lot of times you're just limited to using Google and seeing what you can find for that particular device you care about. I highly recommend the XDA forums. I think it's xda-forums.org or com, one of those. So X-Ray Delta Alpha, XDA. And you'll find a forum there for pretty much every device you can think of. And a lot of times they'll have methods for rooting and things like that. But again, it just wildly varies by device, by manufacturer. There's no one tool that will work every time. Hope that makes more sense.
I think it does. In relation to that too, just as an aside, you know, have you run into problems where you have locked bootloaders that you got to get around to, and what do you do with that?
Yes. So that's actually something we talk a lot about in the book. The reason that I'm able to do this on this phone is that it was already rooted. Before I was able to root the phone, I had to unlock the bootloader because by default, HTC sends it out with a locked bootloader. And the process of unlocking the bootloader required wiping the user data. So if you come across a phone where the bootloader is locked and it's not already rooted for you, there's probably going to be very little you can do. And like I said, in the book, we go into a lot of detail on that sort of thing. But yeah, if the bootloader is locked, you don't have too many options as far as rooting goes. There aren't very many public roots out there that will work if the bootloader is locked.
Okay. Somebody, Miroslav, you had asked again if to repeat the last answers. If you could just put in the Q&A app if that was covered, what you wanted answered. If not, just put it back in there, and I'll have Donnie repeat that for you. Philip Weber says, have you tested getting an unrooted phone, rooting it, and then using your tool to get RAM? What has been the success, assuming you were able to root without powering the phone down during the rooting process? Or will this only work if the user rooted the phone and then started using it?
I haven't tested it, but there's no reason it shouldn't work if you can do the root without rebooting the device.
Okay. So once you reboot it, obviously TempFS is wiped and that's it.
Right.
Okay. Have you ever seen anything, just get thrown randomly onto the flash memory from RAM?
I'm sorry, what?
Have you ever seen anything randomly get written to RAM in your testing? Like, I mean, not RAM. You have something in RAM, you shut it down, you turn it on. Obviously, TempFS gets written over.
Mm-hmm.
Have you ever seen any fragments go to unallocated space or anything like that in your testing?
Not that I've come across, no.
Okay.
I haven't seen anything like a page file or something on Hyperfile on Windows. I haven't seen anything like that.
Okay. Miroslav also asked, did you try to make a RAM acquisition and test it with volatility? I think you kind of talked about a little bit about getting a parser and volatility.
Right. Yeah, you got to have a plugin for volatility to parse your data, and we just haven't gone very far down that path.
Okay. I did invite James, but he hasn't appeared.
He's actually in my office right now.
Is he? Well, if you want him to just step into the frame, we can do that.
He's got one of those faces for radio.
Does anybody have any questions for the author of the program, ma'am? James, if you don't want to appear on camera, you can just shout it out if you want.
Oh, he's coming. He's coming.
Nice to meet you, James. I haven't met you before.
Nice to meet you. Hello, everyone.
So does anybody have any questions about the tool itself, that technical questions that James could answer? I have one, actually, while people are thinking if they want anything. So Donnie mentioned having a plugin structure. What programming language is the tool written in?
This program is written in C. It's
C?
Yes, C.
So if somebody were to submit a plugin to you, they would have to do it in C as well, or are you going to make it so that they could do it a different way?
No, volatility is written in Python, as I suspect, and the plugins will be written in Python as well. The plugin would work against the data I output, which is the raw data Donnie was just showing you in the Hex editor. It wouldn't have nothing to do with my C program.
Okay, all right. And so I'm assuming too that there would be a way that people could write their plugins and then have them work with the program. And Donnie, I think, mentioned maybe a GUI interface at some point or another down the road. Is that correct?
Sure. If there's demand or if there's the interest from the community for it, that is absolutely a possibility.
Okay, great. Anybody have any more questions for James that I can address for them that they want me to ask? I had like I said, I just asked for just had a couple here. No? All right. Well, thanks, James, for popping in. And I suppose you guys are both listed in the GitHub repository, or is it just one of you?
We actually have in the source for our code one email address that'll go to both of us.
Okay. All right. So yeah, they can ask that, and certainly if anybody on this has any questions, I can forward them over to James. And if there's a lot of interest out there right now, we can certainly do a live Q&A with Donnie and James. They can address questions. You could, if you wanted to, you can ask them anything, or ask them to test specific things so that you could get some answers, and we're certainly happy to have that arranged. So I think what we're going to do now, Donnie, is we're going to give, as we wrap up, I think we'll give away our giveaways. So what I have here is a random number generator, and I have a list of everybody that registered. Not everybody's online, but you know that doesn't matter. You registered, so we'll send you out stuff. I think the first thing we're going to give away, I'm going to save the big one for last. The first thing we're going to give away is, and I'm going to turn my camera on real quick. Here is a copy of my book, Google Earth Forensics, and I'm going to choose somebody for that. So I'm going to get the old random number generator out here, and I'm going to generate a number, and that number is 45. So the line number on 45 is, and I don't know if this person's online or not, but it is, well, it's my good friend Brian Farnsworth. So Brian, you have won a copy of my book. I know you're thrilled at that. But yeah, well, I will go ahead and send you a book, the book out to you, and I already have your address, but I will send you a confirmation email about that. So Brian, you are the happy winner of Google Earth Forensics. Read it and learn well. I think we're going to give away a copy of your book now, Donnie.
All
so,
right. So I get to do the sexy publicity shot too.
Yes, yeah, sexy publicity shot there. And let's see here. I just want to do one quick thing here. And I'm going to put this up here. Maybe. All right, I'm going to generate this random number. And you can see up on there, I'm doing a little shameless self-promotion right now. We do have a class that has been written by Donnie. It's available at wildpcsmobileforensics.com/advanced-android-forensics. This class does cover the stuff that Donnie talked about today, and goes into a lot more depth. And one of the cool things about this course too is that you actually get to write your own tool. Isn't that correct, Donnie?
Yep.
So our lucky winner is number 16, and we'll find out who that person is. By the way, if you signed up on some kind of false email, I can't get your prize to you, so I'm sorry about that. We have Bob, looks like it is Robert M. at CC, Texas. So Bob, you are the winner of Donnie's Learning Android Forensics book, and we'll send you a confirmation email and send that out to you. And then finally, our final giveaway, the big one, this one's worth $3,000, is you get a free seat at the Learning Android Forensics class, the Advanced Android Forensics class that we have here, the one that I just mentioned, and it's on my screen at the moment. This free seat does not expire. We have 2 courses coming up. If you check the Showcase app, you can click on over to that page on our site. We have 2 classes right now, one in August, which will be in our Springfield, Virginia location. And we have another one happening in September that will be here in Colorado, in Larimer County, at the Larimer County Sheriff's Office. That's in Fort Collins, Colorado. So that will be in September. We'll be adding more classes, maybe even into the 4th quarter of this year, but certainly into 2016, we have more of these classes. And so this does not expire. And is good for any seat in the class when it is useful for you to do it. So it's about a $3,000 value there. So I'm going to give out that free seat now to one lucky individual. And that number was 114. So number 114. I'm just going to check the Q&A. Is anybody complaining that they can't hear me or understand me? Looks like you can. So 114 is Looks like Pete McGovern. So Pete, I will be emailing you with the details of that, and congratulations to you. Congratulations to everybody that won something today. And in closing, I'd like to thank you on behalf of WOW PCS Mobile Forensics, Tom Yang and the crew there. Thank you, Donnie, for taking time out of your day to present for us. We do have another event coming up. It'll be next Friday. The announcement for that will be coming out later on today. That will be on the Windows Shadow copy. Our guest presenter is going to be Zeke Thackeray. He is the global lead trainer for Get Data, and he's going to be discussing the Windows Shadow copy file, why it's important, and he'll be demonstrating most of his techniques, if not all of them, on the brand new tool from Get Data, Forensic Explorer. So we'll be giving out some things there too, some free prizes there, so you want to mark your calendars and attend that as well. Lastly, please do follow us on Twitter and Facebook, our Google Plus page, as well as our LinkedIn company page. And I want to make an announcement too that starting Monday we will have a grand opening sale for our flagship JTAG class. It's going to be 10% off, just for 2 weeks only. So starting Monday, if you have any plans at all to attend a JTAG course, I would suggest that you sign up now. That's a $395 savings on that. So 10% off for 2 weeks. It'll start on the 15th of June and it'll end 15 days from there. So let's see. We have a couple questions before we leave. Somebody said they don't see anything but Donnie in a little window. I don't know, Donnie, are you seeing me?
I see you.
You can hear me though.
I can hear you.
James, can you hear me? Because it doesn't matter whether you see my ugly mug or not, as long as you can hear me. Let me know if you could at least hear me. We don't need to see me. In fact, I think I'll just turn my my camera off. Miroslav asked again, Donnie, where this tool mem can be found. And Miroslav, if you click on the showcase link, you'll see a link to the repository for in GitHub for the tool, so you can grab it there and download that there. Also, I will be following up with everybody with a link to the file itself, so you'll have that. And this live event, and again, this is live. Okay, great, James. I'm glad you can hear me. That's I gave you all the important information voice-wise, and like I said, we all don't need to see my face. I'm no George Clooney. So that'll be this will be recorded, and we'll have it on our Google Plus page, our YouTube channel, as well as on our blog. So you can go back and review the stuff that we talked about and see what Donnie did. And thank you too for attending, MJ. That's awesome. Thanks a lot. So we'll follow up on that. So with that, I think we're going to end the broadcast. And again, thank you very much, Donnie, for taking time out. Please, again, follow us on Twitter and Facebook and Google Plus, and check us out at wowpcsmobileforensics.com. Thanks a lot, everybody, and we'll be talking with you soon. Thanks, Donnie.
Thanks, Michael.